Good morning, everybody. Today is February 16th, and this is the Cluster API provider nested office hours. I'm going to trip up on trying to say that every single time. But anyways, this is a recorded meeting and will be posted to YouTube. So don't say anything you don't want posted up there. We have a pretty short agenda so far. So please make sure you add your name to that Google Doc. We have 2 items on there, and we don't have any new folks. So no introductions or anything like that. And I don't have any PSAs to call out. So we can just jump into this. Vince, if you want to take over and start talking about CAPI dev environments or test environments.
Test environment, yeah. So I need screen share capabilities.
You should have it.
All right. So we briefly talked like last time about like test env, what's so great about it, what's not so great about it. And I guess like there were a few questions about like how do we, like go from like having nothing to actually having like a test environment. And also like how do we get to a place where like we could spin up multiple test environment if we wanted to. Controller runtime actually adds like a lot of these things, like they're built in controller runtime. This is the CAPI main branch, and right now we're using controller runtime 0.82, which is one of the latest releases. And I'm gonna walk through like just like how do we set up these controllers and like how do we test them. There is also like some sort of like super type that we have here, like this test environment, which is built on top of controller runtime. So if you're not familiar with like how CAP is structured, but I think everybody here is like kind of like familiar with it. It's like we have a management cluster and a workload cluster. And a lot of times like we need to test both. And there's a couple of ways to go about this. Like you could have, for example, you could pretend that like the same executing control plane that you're connected to is both a workload and a management cluster, because that is a supported use case. Or you could create like 2 different test environments with their own control plane and etcd that then would act like one as a management cluster and one as the workload cluster. For controllers, what we actually are doing here is like the first thing is like you might see here is that we define a test environment and we say, okay, like I want to create a new test environment. But what does this do is actually like kind of like reusing the end test from controller runtime to say, hey, I want to spin up a new test environment. What mtest does under the hood is actually like pretty nice. Like there is a fetch external binaries shell script. Cube Builder has published Cube API server and etcd binaries for both Darwin and Linux, I believe, so far. I'm not sure if there are like ARMS builds or anything like that yet, but we can add support for it because like we can just have to cross build there. But what this script does is that like it will download locally if you don't have in a temporary folder these 2 binaries for the version that you're specifying. So for example, here we're testing the minimum version of the management and workload cluster that we want to support. So in this case, like it's 119.2 for the management cluster. So this will download those binaries locally and make sure that like when you create a new test environment, it will spin those binaries up in a process group. Any questions so far? Not all the versions are published here. So like if you need a different version, like you might want to check out like this storage link, just this part before the archive name, and that should show you like which versions are published. If you need other versions, like we can work with the Cube Builder folks to actually publish them. So under the hood, the test environment is actually quite complicated, like how like it all ties everything up together, especially because it also supports webhooks, which it actually is really nice. But it will spin up the API server it will spin up etcd that you can see here, and it will find those binaries first, and then it will try to spin it up. It also configured like things like the rest config, so that like you can do like super like a lot of requests like per second, and like have a high burst, etc. But the really nice thing is like you can actually configure everything in a control plane. So like there's a whole thing here like about the API server. So you could set like secure port if you want to. You could set the path where to find or like define the binaries, or you could find the arguments. If you have another etcd, like you could potentially configure to use it. We don't do that. We just spin up two processes, and then it has happened sometimes that like we have found errors in the API server itself. And one nice thing about testing is that actually like you can like say like attach control plane output, and then everything will go to some output in error as needed. You could also use an existing cluster if you wanted to. So like this will just like defeat the purpose of like having kind of like segregated like environments. But you know, if you have that use case, that's great as well. You can also install all the CRDs. So like you could give the test environment, say like I want all these CRDs to be installed. You can give the CRDs in here, or you could say like I want them this install options, which is like you could give them paths. And so this would actually be set usually to the config directory that you have in here. So like in the basis, so like all of these CRDs. So that when testm starts, like it will just go and find those CRDs and install them for you, and you don't have to do like anything else. You can also clean them up after you use them, etc. So there is like a lot of good support about it. And if you have webhooks, this is also like why we kind of like have a structure that then has that environment struct, is because we install our own webhooks and like webhooks, and we want to make sure that like all the webhooks are registered and up and running for those CRDs. You'll see here there's like a custom function, like a how to install webhooks, and you know, we don't have to go through this, but like it's pretty much saying, I'm going to go find all the webhook and register them from the config directory. This is probably something that we can add to control runtime itself in the future. But what's so good about having webhooks in here? You get conversion, you get validation, you get defaulting, all of in testenv. So when you like have this integration test up and running, you're creating an object, it will actually go through the same code path that like a kubectl apply would go through, which is really powerful if you want to test like a user behavior as well. Once all of this is done, like we usually return the struct, which the manager client and config, and then a suite in here, like we just create the test environment, and then we register like all the reconcilers in here, and then we start the manager like we would start in a main.go file. And then we wait for it to be elected. We don't use lead election here. This is just because this should be called something else, but this waits for all the reconciles to be up and all the caches to have started. So this is pretty important to wait for that to happen before continuing. Also wait for webhooks to start, because the services might take a little bit to actually like link that all up together. And then it will run all the tests, and then it will stop the suite. So what happens when we do run a test? So as an example, we could go into actually questions.
Yeah, I'm going to throw out one question, because this is fascinating, and some of the stuff that I haven't actually checked out yet. Most of the tests that I've ever seen for controller runtime and KubeBuilder have been just like linked off of docs, and they were pointing to like the Databricks Azure one, which has a very different implementation. I mean, similar but very different in terms of like some of these like gotchas that you found. This is just a complete blanket statement. Is any of this ever going to end up more into KubeBuilder or controller runtime's docs a little bit? Because it doesn't feel like this is all like this is so much more advanced than what we get out of like what I've typically seen, and I'm stoked by it.
Yeah, I feel like, I mean, we have been using it for 2 years plus at this point. So like we're pretty far ahead in terms of like what our requirements have been and how we want to use it. In terms of dogs, like, yes, like I would hope that like these things like actually are gonna, like the goal is like actually to build them in here, but like bring up as much as possible in controller runtime, because then all the projects can reuse it. I would love if actually these things would actually be a little bit easier, like so that you don't even have to register like, like you could auto discover reconcilers in the same package and things like that. Sort of like really advanced scenarios
Sure.
that like we'll have to think about. Yeah.
Yeah,
But yeah,
because
the
this gets
docs
so
should be there.
Yeah, because this gets so screwy when you do like the multi-group true. Like you end up with multiple suite tests, and they can't run they can't run parallel because of the way that InV test is set up in at least base queue builder. And so I've run into a ton of gotchas around that, and this is
Wait,
just
really?
uh-huh.
Oh,
I'll show,
interesting.
we'll talk about it later. I've been meaning to finally go file some issues to try and fix some of that stuff, where the like some of the ways that you can scaffold a project will screw you in the long run for being able to do some of these things. And a lot of it doesn't point to make your suite test like main.go. It's almost like test the individual controllers that are in here, especially when you go multi-group, test the individual controllers in here, but then it really screws up like massive test full test suite runs. Anyways, that's an aside. This is fantastic. I'll let you keep going.
Yeah, we did the complete opposite. We're like, well, we want to run all the controllers in a package, and maybe even like other packages controllers if possible, because the system has to be tested together. Like it's like really uncommon that like I could test, for example, like the cluster controller or like the machine controller without the cluster controller, unless like I start making a test to behave like that cluster controller, which is another option. But truthfully, like in production environments, like they will have to behave together. And kind of this like, yeah, like the reconciliation loops like have to behave together and stuff like that.
Cool. Thanks for that.
So in terms of like, for example, so one of the change that we have made in Cluster API versus Queue Builder, you might have noticed that like a Queue Builder has, so for example, let me take, I think this one still has it. Has this before suite and after suite usually. So Ginkgo's not bad, but one thing that we didn't like in Copy is that like you lose like the ability to run single tests if you wanted to. So as an example, like if I go into machine delete policy, if I click this run test in VS Code, I cannot do that with Ginkgo, but if I can do that in here, and if I click it, like it's not going to break, but it would run the test environment first, as you can see, and then we actually run only that test and that test only, rather than like try to spin up the whole. So like, yeah, like it just ran test machine to be deleted, but instead, like if I go into the other package, we haven't been able to do all of them yet. So for example, this is still on the old one. I cannot run the suite, or I cannot run, these are like unit tests. But yeah, I cannot run this one only if I wanted to. So like if I'm developing and I'm changing this one, or like, I don't know, this line of code, the only way that I can run this is like actually go and type it out like the whole package, I guess, or I could like, try to do file tests or something. But really, like you can just say like, I want to just test this it condition. So we went kind of the opposite direction of this, and we're trying to move all the other suites as well to use test main, because test main works well, and it kind of, yeah. So I can just run one test or debug one test if I wanted to. So one other thing that like we have been doing here is like if I get the machine deployment controller, for example, so like as you can see, like there is like some mix of things in here, but like which is fine. One thing that we have been doing is the namespace segregation of like these tests. And this is sure all things that like are going to be documented at some point. So for example, here we create a new namespace, then create the cluster. I think there was a question like last time, like, can I delete the namespace? Yes, we were able to delete the namespace, for example, for, after each test. So like if this is run, and then there is like a bunch of tests in here, like after each test is run, we create and delete the namespace, so that like the next one is gonna like be segregated that namespace, and the namespace is gonna be created with, I guess like if this is using the same name, it should really use a generating name, but like that's a topic for a different time. Whenever we can, we would use generating name instead of like a name, and make sure that like if you have a test that's running, like that if you want to do count equals true for example, that like a Go supports, and you want to run that test twice, you don't rely on naming to actually say like, hey, I want to create this object and then delete it or modify it or something. In that way, like if you don't have proper deletion in place, like you don't get stuck with failing tests if they run like twice in a row with the same test environment. So that's like the reproducible aspect of it. The other nice thing about testenv is something that we have found that you folks probably want to use this as well. It's like, how can I test things that I don't know anything about? I mentioned like we have the concept providers, and like these providers have contracts. So like, how do we go about testing these contracts? The thing about testenv that like it's actually really useful is that you can inject CRDs on the fly. So for example, here you can see like we have an infrastructure cluster CRD. This CRD doesn't exist anything except for in tests. And there is pretty much like a whole, so like we create these CRDs in tests, and we register the CRD as well when testenv comes up, so that you could do the same thing pretty much. There is a whole hack, and I'm trying to find it, that you can do to say, I want to register these CRDs, and these CRDs like we pretty much disable the open API spec, so that like it's just say like plain object, like it can go, anything can go in here, and it will also preserve the fields, because like newer version of the API server actually won't let you preserve the fields unless you opt into that behavior. So yeah, we try to kind of like make sure that that's in place. Any questions before I move forward?
Hi Vince, it's Charles. I have some questions. It's really cool. I didn't realize control runtime provide this cool testing environment. I think this testing environment can actually be used for any controller that develop based on a control runtime or any other like client Go controller. Is that right?
This would probably work best with controllers that are part of controller runtime. So like that you would create with controller runtime. I wouldn't see why like it wouldn't work with client Go plain informers and like just like more generic controllers, but I have not tested that, so I'm not able to speak to that.
Okay, I see. And I noticed that we only have Kubi API server and etcd in a control plan. So if I wanted to test something related to deployment or stateful set, is that possible?
You would need the controller manager, if I remember correctly, for those. So probably, so like you could create it, but it won't actually like spin up like a deployment, or because like it doesn't have any nodes underneath.
Okay, so is that in the roadmap? Like in the future, maybe we will add the controller manager into the test framework, and we can do some more cool testing?
I have not seen like an ask for it in controller runtime. It would be probably hard because this,
Mhm.
yeah, I'm not sure if, because like there might be no CRI and CNI like locally. So like it gets like exponentially complicated rather than just like run the API server in etcd.
Mhm.
But what you're saying is actually like, so these are like usually folks like call these integration tests.
Right.
And we usually do end-to-end tests with kind. So we have a
Okay.
whole like other provider, which is CapD, which is inside of Cluster API, that you could create like, you could spin up like a kind-based cluster with Cluster API. So you could just have like a test cluster in there and then create the deployments and, you know, like everything that you want to create like on that.
Okay.
So yeah, we have the foundations in Cluster API to spin up like a kind cluster that then you can test for other things. But
I see.
within controller runtime, I would see it really, yeah, it wouldn't be super doable.
So this test framework is aims at testing only the workload or things related to the API server or etcd, like add a new object, delete the object. Is that right?
I would say like it's definitely meant to be testing like controllers' behaviors rather than like the whole chain of systems to get there. So for example, like if you see Cluster API has like so many controllers and some of them have to work like really closely with each other. So for example, here, like the machine cluster controller, a machine cannot be created without a cluster, but the cluster has to be reconciled and some fields have to be in place for the machine to
I see.
move forward.
Okay, that makes sense. Yeah.
So those kind of behavior, like those are testable in here. Other behaviors, which is like a more like, for example, hey, I want to check the status of a node in a cluster. We would either mock it or create a fake node, which you know, it won't be reconciled.
Yeah, I see. Yeah, that makes sense. Yeah, because sometimes when I write the controller, sometimes I wanted to reconcile some other workload like deployment, the stateful set, or even pods. So I'm thinking about, yeah, we can add some fake or mock objecting to the API server. Yeah, that's all my question. Thank you.
Yeah, we've actually done something very similar to that for a couple controllers that I've been on testing, where we've gone through and basically we were trying to do reconciliation based on specific states that like a deployment was going through. And if it got into a bad state, we wanted to handle it in a specific way. And so we just mocked exactly a deployment object getting passed into it, which worked. But yeah, it doesn't solve for the full E to E test that you eventually want to run too.
Yeah, I see. Yeah, that's really cool. Yeah, I will try it out. Yeah.
And feel free to reach out, like, and I can post links to the Cluster API ones, and like if you folks need.
Is the Cluster API one is in a master branch, or?
Yeah, you can just look at the Cluster API repo, like just here, and
Cool. Thanks for dropping that. I'll put that in
I
the
see.
agenda as well. This is fantastic. Thanks for taking us on that tour. I'm going to ask a couple more questions. So the test main setup that you actually did, and not using Ginkgo for all that, for Ginkgo, yeah, whatever it's called, that project for this. Do you see that permeating outside of Cluster API? I mean, being that you are on, you head up QBuilder and controller runtime as well. Is that something that we would be changing the community as well to do, or exploring from that side?
We could
Because I
provide
agree,
examples.
all the same problems that you called out, I think are like useful cases for for reasons why we wouldn't be prescriptive in those tools.
So I have not contributed to QBuild directly, but yeah, controller runtime, we can provide examples on like how to do so. Rewriting all the tests is like I'm not a fan of, but we can probably say like, hey, like maybe new test we can write with like the new a new test mean or something. But yeah, like those who are paying and like going forward that we actually don't allow, like in Cappy, we don't allow new tests to be written with Ginkgo. We just say like, hey, you need to kind of move to the test main unless it's, you know, fixing the old test or something. Yeah.
Okay, cool. And for the setup of that, is that just get called? Does test main just get called for every single test run, or are you calling it from somewhere else that wasn't actually, that I didn't see? Or I might have missed that.
Test main is actually called from Go directly when you do Go test. So it's the first function that actually gets called when a package after init, the package when you run test, it will run test main first.
So it's basically the suite setup or the before suite call, but not for Ginkgo, is what you're getting.
No, it's built in Go, which is great, which is why it's super nice. Yeah.
Okay, cool. That was fantastic. I in the middle of this, because it was so good, I called a couple more people from our team in. So you might have saw a couple more people jump in. And they might have missed a little bit of this, but we can give you some primers on or some notes about what Vince was talking about. Gabby and Aditya. Thank you for doing this. I really appreciate it. Do you want to move on to Wade? Do you want to talk about the synchronization proposal?
Yeah. Let me share my screen.
Give me 1 second. All right, you should have the permissions.
Okay. So can you see this screen?
Yep, looks good.
Synchronization in multi-tenancy sync. So basically, I had a brief discussion with Chris yesterday and the day before. So we would like to have example code implement in current multi-tenancy syncer code, so that everyone can use this as a base to synchronize some annotated CRDs from supercluster to the virtual cluster that tenant created. So this document is try to give a high level view what we want to do and try to get some feedback from the community that if this is a good approach or not, and then we will do some implementation after that. So the main objective, I think, for this document is try to install the CRD from supercluster to the virtual cluster when the virtual cluster is started. And also we will dynamically build a scheme and CR clients when the synchronization started. And we will also construct example CR sync code on the side of this current virtual syncer code. We don't want to put all the CRD syncer code in the current multi-tenancy syncer code base, because I think most CR code is proprietary. So probably people don't want to share it on the community. So the basic idea is in this diagram. Basically, we want to reuse the entire multi-tenancy syncer code as a library or infrastructure, and we build our proprietary code on the sideline in a proprietary repo. And what we want to reuse is most of the component in the current virtual cluster multi-tenancy syncer code. And only one module will be introduced, will be an optional module that's based on the configuration option, that this module is in the listener package that monitor the supercluster CRD creation. And this CRD need to be have a annotation called a tenancy super public. This can be we can still discuss on this annotation. But once this CRD has this annotation, this optional CRD syncer will try to load this CRD into the newly created tenant virtual cluster. And for all the virtual cluster, we will install the CRD without any other options. And this will be also automatically install this new CRD scheme into the scheme which is currently exists in the multi-tenancy code. So with this two options, that all the CRD has been installed, and then user can start to play with the synchronization code. The synchronization code in a user repo is mainly a main function, which is replace the current main in this multi-tenancy code, because it need to have built locally. And also we need to try to select the synchronization feature, including the CRD synchronization, as well as the current core v1 or standard Kubernetes resource synchronization. According to current code base, that we need to do an init function that to make sure what we want the resource type need to be registered into the plugin, so that this code can be start with the new resource type controllers and start to reconcile all the objects. So this is basically is this structure, but we think that all this need to be done at the compile time. We do not want to support the dynamically installation like a CRD when dynamically installed. We also don't want to support the customized resource syncer when this already running and user want to inject into a new syncer while it is running. I think currently we have quite some issue need to be fixed before we can do fully dynamic load of this new synchronization modules. And so this is basically, we were mostly using the controller runtime to do all this client set and as well as the testing. And I think basically the idea is like that. Do you have any questions or concerns based on this kind of implementation structure?
We'll definitely want to get Faye's eyes on this as well.
Yeah.
Chow, if you have any feedback as well, that'd be useful.
Yeah, so the basic idea, I think, is just put this two code base separate instead of fully integrate into it. And I will going to implement this either in this directory example, or what Faye is doing with experiment experiment directory, that to put this as a new main and all the example resource syncer, custom resource syncer in this directory, and make sure we have at least a template or example to teach user how we can implement a customized resource syncer on top of that.
So are we going to create a new repo just for the customer code?
Yeah. So currently, I think I will put. I hope I can put into an example, or another option is put the experiment. That I have a like the new code Faye is doing. We have a main, like he's a scheduler code. We have a main. We have a package within this experiment or with example code, so that we can build this CRD syncer code, but to refer all this main component to the current multi-tenancy syncer code.
I see. Yeah, I don't have any thoughts right now, but I think it should be better if we can get Faye to take a look of this proposal. Mm-hmm.
Okay, I will ping Pei to make sure he review it, and I will going to implement an example somewhere in that.
Yep. Mm-hmm. Mm-hmm.
Cool. Thanks for showing us.
Okay.
I've also CC'd Faye on the issue.
Okay.
So I assume he'll get a ping from that.
Yeah, I also CC'd another folks working on this area, I think with Faye's colleague, and also make sure he is aware of that change. We can do the synchronization work together.
Perfect. Appreciate you doing that. All right, we are at the end of our agenda. Does anybody have anything they want to bring up? Any questions? All righty, well, we can cut it about 20 minutes early and give everybody back some time. Thanks everybody again. And this will be posted to YouTube after this. We'll see y'all next week.
Yep. Thank you.
Thank
See ya.
you.
Thank you.